Hi everyone, so today I will be discussing the January 2020 Mechanics paper 1. So we'll start with question number 1. Two particles P and Q of masses M1 and M2 respectively are moving on a smooth horizontal plane. The particles are moving towards each other in opposite directions along the same straight line when they collide directly. Okay, so you have the particles moving towards each other. So there are two particles that are moving towards each other along the same straight line when they collide directly. Immediately before the collision, both particles are moving with speed u. Okay, immediately before the collision, shall I draw the particles? Okay, immediately before the collision, both of the particles are moving towards each other with speed u. This one's mass is m1, this one's mass is m2. So two particles mass is P and named P and Q, right? So I'm marking everything on the diagram. Then they say the particles are moving towards each other in opposite directions along the same straight line when they collide directly. Immediately before the collision, both particles are moving with speed u, which I have marked on my diagram. The direction of motion of each particle is reversed by the collision. Okay, so they say both the particles, the velocities are reversed. So then on top I mark the initial velocities. After impact speeds, I will mark it at the bottom. So we don't need to draw another diagram. So we will mark, I will mark it as x and y. So x is the speed of particle P after the collision, y is the speed of particle Q after the collision. And they have told us that both of these particles are going to what? They are going to the direction of motion of each particle is reversed. Okay, so therefore reverse the directions and use. Okay, can you see I have reversed? So P the P's direction is reversed, Q's direction is reversed. Immediately after the collision, the speed of Q is 1 over 3u. Okay, so I don't need to use y here. Immediately after the collision, the speed of Q is 1 over 3u. Can you see? Find in terms of M2 and u the magnitude of the impulse exerted by P on Q in the collision. Okay, so they wanted to find what? The magnitude of the impulse by P on Q. Now, you know how does the impulse work when the two particles collide? You create what? An instantaneous and equal and opposite force called the impulse. So the impulse on P acts to the left direction while the impulse on Q acts to the right direction. And you know these two impulses are equal in magnitude and opposite in direction. So then if you want to find the impulse in terms of M2 and U, you better apply I equal mv minus mu to whom? To particle P or to particle Q? You have to apply to particle Q. Okay? So because both the impulses are equal, but still on particle P we get it in terms of m1. So on particle Q, so they say exerted by P on Q. Okay, so even if it is Q on P, still it's the exact same impulse. There's no difference. Okay, so shall we apply I equal mv minus mu for part A? I equals mv minus mu. So I'm applying on particle Q. When you apply impulse equation, it's really important that you mention the positive direction that you are choosing. So I'm choosing positive direction to be what? So I will choose the right side to be the positive direction because Q has impulse to the right direction. Okay, so let's get the value of impulse. I equals mass is m2. V is the final velocity, that is 1 over 3u. So make sure you check the direction, that's to the right side. Minus again mass is m2 into initial velocity u is u, but it is to the left side. Can you see? Okay, so then let's fix this. You know I want everything to be onto the right side because the impulse on Q is to the right side. So I will change this one. Let me write this here, 1 over 3 m2 times u. So I will change this direction. So when I change it, when I change the direction, the negative becomes positive and I get here m2 times u. Do you agree with me? So I can add both of them together, 1 over 3 m2u plus just m2u means it's 1 m2u, isn't it? So 1 over 3 m2u plus 1 m2u, when you add everything together, it gives you how much? 4 over 3 m2u. 1 over 3 plus 1 is 4 over 3 m2u. Do you agree with me? Okay, so moving on to part B, they say find in terms of m1, m2 and u the speed of P immediately after the collision. So how can I find the speed of P immediately after the collision? So what can we use? There are two options that you could go with. You could go with either, because we know the speeds, all these speeds, you could go with the law of conservation of momentum, or you can again go with what? I equals mv minus mu on particle p. Because we know the impulse now, we know that the equal opposite impulse acts on particle p. Which option do you prefer? Okay, so you want to use I equal mv minus mu. So even conservation of linear momentum is also correct. Okay, so you suggest me to use I equals mv minus mu on particle p. So if you are using I equal mv minus mu on particle p, what is the positive direction? Particle p impulse is acting positive in the left side. So make sure you choose the left side. It's extremely important you choose your directions correctly here. So what is the impulse? Impulse on Q and P are equal in magnitude. So it is 4 over 3 m2u. Are you with me? That's the impulse. M, mass of particle P is m1. m1 into velocity v is the final velocity, which is x. And then show the direction. So x is backwards, so we do not have any issue, right? Even the impulse here is backwards, x is backwards. Minus mass is m1 into u. What is the initial velocity? U. U is forward, right? So to the right side. We have u to the right side. So can we work with this? No, right? You know, I need everything to turn to the left direction. Then this we need to fix this here. Shall we fix it? So 4 over 3 m2u equals m1x. This one, when I change the direction, this becomes positive m1u. Are you with me? I change the direction, thereby over here when the direction changes, the negative becomes positive. Okay, so what's our task? Our task is to find the value of x. They are asking you to get the x value. So let's get the x value. 4 over 3 m2u 4 over 3 m2u. I'm taking m1u to the other side as a subtraction equals m1x. Are you with me? Before I take m1 down over here, shall I get the common denominator 3? So then I get here, this is over 1, I'll multiply up and down with 3. So I get here 4m2u over 3 minus 3m1u over 3. I just multiplied up and down with 3. I have a common denominator 3 now. Are you with me? So which means this is under a common denominator 3. 4m2u minus 3m1u equals m1u. m1x, I'm sorry, this should be m1x, right? m1x. So finally, when you make x the subject, what do we get? Taking u out, you get 4 times m2 minus 3 times m1 over 3 times m1. I just brought this m1 down here, and from the top I factorized the u out. Okay, so any equivalent answer, even if you keep it in the any equivalent answer of this, even if the brackets are open, is okay. Okay. So this is an answer you can. This is an answer that you can give for the speed of p after the collision. Okay, even if the brackets are open, 4m2u minus 3m1u over 3m1 is also an acceptable answer. Okay, any equivalent answer for this is okay. Okay, so moving on to the next part, there's a hence. So when they use the word hence, it means what? Hence means use the help of the above part. So part B, part A, use the help of part B, part A. Hence show that m2 is greater than 3 over 4 m1. Okay, how do we show that m2 is greater than 3 over 4 m1? Now you can see we have the speed, actually we found in part B the speed of x, right? The speed of p after the collision, can you see? So this x figure, now to see, now you need an inequality in terms of both m1 and m2. So you can see if you consider the speed of p after the collision, this x, it's in terms of both m1 and m2. So what can we say here to get an inequality? How do we create an inequality? So we can say that this speed, the speed of p after the collision is what? So since they have told us that this is definitely reversing and we use the reverse direction, that this value is definitely what? The answer that we are going to get for x here, will it be, when you input the m1, m2 values, will it be a positive figure or a negative figure? If the direction, if you are sure of the direction that you are using, then your answer is definitely going to be what? Positive. If the direction, now if you are unsure of your direction, then if you get a negative value, then the direction you use is wrong and you have to change it. But in this case, the question says says us that the direction of P and Q are reversed. Therefore, we realize that the direction we use for X here is definitely correct. Which means the answer that I get here for X, the reverse direction should be a what answer? I got this X value considering the given direction, right? The reverse direction. So this answer must definitely be a positive answer or negative answer. It must be positive. Okay, so because sometimes you remember when you use these assumed directions, you get negative answers, and then that means the direction you use is wrong. But here, is this an assumed direction for X? No, it was given in the question, which means X must definitely be a positive answer. So then you can write here for part C, X is definitely greater than 0. Who is X? X was U times 4m2 minus 3m1. 4m2 minus 3m1 divided by 3m1. So this is greater than 0. Are you with me? So u times 4m2 minus 3m1. The 3m1 is a positive digit, so positive figure. So it goes to the other side. We can take it to the other side of the inequality without any issue to the inequality sign. 0 multiplied by 3m1 is 0. And then take u. U is also a positive value, right? U is also a positive figure, so you can divide it off. Divide both sides, so still that also will remove to the other side. We can remove it completely. 0 divided by u is 0. Will not affect the inequality sign because u is a positive figure. Now we can go for our inequality. 4m2 greater than minus 3m1 comes here as plus 3m1. When you bring the negative 3m1 to the other side of the inequality, as plus 3m1, is the inequality sign affected? No, the inequality sign is only affected if you multiply, if you take a number to the other side as a negative number to the other side as a multiplication or division. Okay, so here you are just taking a negative 3m1 to the other side as a positive 3m1. That doesn't affect the inequality sign. So here I get m2 greater than, now here I am taking 4 as a division. So this is a positive 4, therefore will not affect the inequality sign. So I get here 3 over 4m1. m2 is greater than 3 over 4m1. So this is the show that. Okay, so is this clear? Okay, moving on to question number 2. A non-uniform beam AB has length 6 meter and weight W newtons. The beam is supported in equilibrium in a horizontal position by 2 vertical ropes, one attached to the beam at A and the other attached to the beam at C, where CB equals 1.5 meter as shown in figure 1. The center of mass of the beam is 2.625 meter from A. So non-uniform, meaning center of mass is not at the center. So they have actually given you the distance to the center of mass. Can you see? So center of mass is acting at a distance. So here, over here, the weight is acting. So let's say the center of mass acting position is G, and they have told you the distance from A to the center of mass is 2.625. Are you with me? 2.625, this particular distance. Okay, and then what do they say? The ropes are modeled as light strings. The beam is modeled as a non-uniform rod. Given that the tension in the rope attached at C is 20 Newton greater than the tension in the rope attached at A. So which one is greater? The tension in C is 20 newtons more than, 20 newtons greater than the tension in the rope attached to A. So which one is T? Which one is T plus 20? Which one is T? Which one is T plus 20? The one in C is higher, right? So one in C is higher by how much? By 20 newtons. So which one is T? The one in A is T, while the one in T is T plus 20. Are you with me? Because they say the tension in the rope attached at C is 20 newtons greater than the tension in the rope attached at A. Find the value of W. Okay, so how do we find the value of W? In these kinds of questions, there are just two things to do, right? You take moments around a given point and you apply vertical equilibrium. So shall I first get vertical equilibrium? So how do we get the vertical equilibrium? So we get here vertical equilibrium, and the upward forces are balancing out with the downward forces. So what is it? So when you consider vertical equilibrium, what are the upward forces we have here? T and T plus 20. Are you with me? T and T plus 20 balances out with whom? The W. So I get here 2T plus 20 equals W. Are you with me? 2t plus 20 equals W. Okay. So now now we are supposed to get the value of W. Okay, how can we get the value of W? What's the next thing that you did here? You took moments. So moments around which point? You can take around any point as you see wish. So yeah, we will take moments around A. Okay, you can take moments around any point, either A or G or C or B. So I think taking moments around A is easier, right? Because we know all the distances were directly. So I will take moments around A and take clockwise as positive. Okay, so how does it work? Moments around A. So when you take moments around A, the tension at A will not come because it passes through A. Okay, so then the next one I have to consider is W. W gives a clockwise moment or anti-clockwise moment around A. You can see W pulls down around A, right? So it's giving you a clockwise moment. So then mass into distance, W into 2.625. Do you agree with me? W into 2.625, it's a clockwise moment, and then the T plus 20 gives you a what kind of moment around A? It gives you an anti-clockwise moment. Can you see? It's pulling in this way. It gives an anti-clockwise moment around A. Okay? So therefore that is a negative. T plus 20 into how much is the distance? How much is the distance? So you have to subtract, right? The whole distance is 6 meters. 6 minus 1.5 is 4.5 meters. Is that correct? .5 meters. So here T plus 20 into 4.5. Do you agree with me? Okay, so then this is equal to 0. There are no other forces here that gives moments. Only W and T plus 20. Now it's a matter of solving a pair of simultaneous equations. Okay, so first let's simplify. W into 2.625 minus T plus 20, so we need to actually substitute from here. Okay, shall I make, we are supposed to find the value of W. So if we could replace T here, shall we make T the subject? So 2.625 W equals T plus 20 into 4.5. Is this okay? I brought the minus T plus 20 into 4.5 to the other side. Now divide by 4.5, what do we get? 2.625 W divide by 4.5. Divide 2.625 by 4.5. What is the answer? I'm going to bring this 4.5 as a division. 7 over 2, which means 7 over 12. Right, so I get 7 over 12 W. Is that correct? 7 over 12. And then let's get the T value. T is 7 over 12 W minus 20. Do you agree with me? Is this okay? Okay, did you come to this point? Okay, so then what do we do now? Now substitute the W value into the equation. So substitute. So 2T plus 20 equals W. So 2 times T is 7 over 12 W minus 20 plus 20 equal W. So open the bracket. 2 into 7 over 12 is 7 over 6 W, right? Minus 40 plus 20 equals W. So how much do we get here? Take the W terms to one side. So 7 over 6 W minus 20 equals W, right? So I'll bring the W term over here and I'll bring the minus 20 to the other side, making W the subject. I'll bring all the W terms to one side. 7 over 6 W minus W equals 20. 7 over 6 minus 1 is how much? 1 over 6 W equals 20, which gives me W equals, take the 6 to the other side, 6 times 20 is 120 newtons. So can you see, do not take decimals at any point here, because if you do at this point for 7 over 12, if you use a decimal answer, you will not be able to get this exact answer. Okay, so make sure you keep the fraction over there and be careful when you are solving the simultaneous equation. Okay, is this clear? So W should be equal to 120 directly. And then they ask in the next one, state how you have used the fact that the beam is modeled as a rod. So again, in your M1 book, in the chapter 1, in the book, you can see they have given you a table with the model and the modeling assumption. So those facts in the table should be you should kind of have it memorized. So in the table you can see for a beam, when the beam is modeled as a rod, what do they say? So what are the assumptions? How have you used the fact that the beam is modeled as a rod? So it is, the beam is rigid or it doesn't bend. So those things are mentioned, right? So you can say here, how have we used the fact that the beam is modeled as a rod? The beam is rigid, or you can say, or it does not bend, or it doesn't bend. Okay, is this okay? Okay, so to do this sum, you can actually, without going for vertical equilibrium, you could make two, you just need to make two simultaneous equations here. So taking moments around A and even taking moments around C, you could get a pair of simultaneous equations that also will work. Okay, so there are many other ways of getting the answer, but you must end up getting the exact same answer. As long as your workings and methods are correct, you will get the full marks. Okay. Okay, question number 3, they say a particle P is projected vertically upwards with speed u from a fixed point O. At the instant when P reaches its greatest height h above O, a second particle Q is projected with speed half u vertically upwards from O. Okay, so let's draw a quick sketch to understand what's going on here. So this is the point O. So from point O, first your particle P is projected vertically upwards with speed u. So you have particle P, they are projecting it upwards with speed u, meters per second. So this is going to go up. So this travels up and they say at the instant when P reaches its greatest height h. So greatest height is h. Okay, greatest height h above O. Okay, a second particle, okay, so by the time P reaches up at this point, a second particle Q is projected with speed half u vertically upwards from O. Okay, so by the time P comes up over here, you project another particle. Okay, so when P is at that point from O, so directly at O, we again project another particle called Q. And Q is projected with speed half u. Are you with me? So this is P. I will just draw Q over here, but actually Q is also projected from the same point, okay? And Q is projected upwards with a speed of half u. Are you with me? Okay, so then find capital H in terms of U and G. Okay, so we'll find capital H. Let me draw it like this. Right. So this is the beginning. This is where P is, and then okay. So I drew this again. So starting at point O, P was projected, and then when P is at the highest point, we immediately below we project another particle Q. Okay. So how do we find H in terms of U and G? What's the equation we use? So we will go with particle P, right? For particle P, we apply what's the equation? We can apply V square equal U square plus 2as. Are you with me? So we can apply the equation V square equal U square plus 2as. Okay, so how does that work? To particle P. So V, final velocity, you know when V reaches the highest point, what's the speed? The initial speed is 0. U is 0 at the highest point. When particle P reaches the greatest height, U is 0. So V square is 0. Starting speed was U, was given as capital U, right? Okay, so this should be capital U. Okay, U square plus 2 into, I will use upwards as positive. So 2 into, this is going to be negative G, because acceleration, gravitational acceleration is downward. So this is negative G. Displacement is capital H. Do you agree? So 0 equal u square minus 2gh. Do you agree with me? So I get here, we are supposed to get h in terms of u and g. So I'll get 2g capital H equals u square. So you get capital H equals u square over 2g. Is that okay? So you get u square over 2g. So this is the answer for part A. Then moving to part B, they say find in terms of capital U and G the time between the instant when Q is projected and the instant when the two particles collide. Okay, 6 marks. You can see this is a major part. Find in terms of capital U and G the time between the instant when Q is projected, so that is at this point, and the instant when the two particles collide. So you have to find the time. That means when Q is projected means when P is at the top, right? So you have to find the time between the instant when Q is projected, or in other words when P is at the top, until the point where the two particles collide. Are you with me? So you have to find the time taken for these two particles to collide. Okay, so Q is traveling up, P is traveling down. You have to find the instance when they collide. So what about the time durations that they take? Okay, so if you consider the time taken for P to move this particular distance and the time taken for Q to move this particular distance, they are same or different? They are? Yeah, now you know particle Q is projected at the exact instant when P reaches the greatest height, right? When P reaches the greatest height, only we project particle Q. So they ask us to find the time between the instant when Q is projected and when the particles collide. So you know Q is projected at the exact time P is at the greatest height. So time taken for P to move down here and time taken for Q to go up or to move this distance, both times are the same. Because both of them start movement at the exact same time. I mean, if you consider the P's time should be considered from this top, from the greatest height, not considering the time that P went to go up. So I'm now considering the time taking P is starting the motion from the greatest height. Okay, so not from here, not that P came down up over here. We are considering the time that P is from the considering the time where P is at the greatest height. From there, time is 0. We consider this as time 0, and this time taken to come here, and the time taken for Q to move from here to here. These two times are equal. Okay, that's what they say in the question. Okay. Okay, so now the thing is just be careful here. Do not think that these two particles will meet at the center of H. That doesn't happen. Okay, they both take the same time to move, but they will not move the same distance, because they have now you see P is starting to move from rest while Q is moving with projected upward with speed half u. So then the distances that they cover will definitely be different. We can't say that they move they meet at the center. Okay, so that we do not know the distances they meet, but we do know that the time they take to move, whatever the distance they move, both the particles will take an equal amount of time. But we cannot say that they move the same distance, because P has an acceleration downward, Q has a deceleration upwards, right? Do you get what I'm saying? Okay, so then what's common here is the time taken. Okay, so we'll say the collision point is PQ, so let's say some point X. Okay, so at the collision point X, the time taken for particle P to move from P to X and particle Q to move from Q to X are, or from O to X are equal. This is point O, right? Okay. So let's find, they are asking you to find the time taken. Find in terms of capital U and G the time between the instant when Q is projected and the instant when the two particles collide. Okay. So shall we, there's only one equation to use here. What's the equation that you're supposed to use? What's the equation you're supposed to use? We will use S equals ut plus half at square. So which one will I will first go with P. I will use this to P, particle P. Okay, are you with me? Okay, so let's get the particle P is going downwards. What's the displacement? So particle P's displacement, give a letter for particle P's displacement. Okay, so we will say displacement of particle P, we will use SP. Okay, so displacement of particle P is SP. Initial velocity is 0, because it's starting at the top. Initial velocity is 0 into time, so the entire term becomes 0 plus half. It's moving downwards. Gravitational G acceleration due to gravity G value is positive into T square. Okay, so displacement of particle P is half gt square. Do you agree with me? Now let's apply S equals ut plus half at square to which person? To Q. So displacement of particle Q is, how do we get the displacement of particle Q? So you can say it's SQ. Okay, displacement of particle, say it's SQ. Displacement moved by particle cube SQ. Initial velocity is, I'm choosing upwards as positive because particle cube is moving upwards. Initial velocity is half u, and time taken is t, because both of them I'm using the same t. The t value taken by both p and q are the same. Don't use t1, t2. Okay, times are the same. And then since this is going upwards, the acceleration due to gravity is negative g. So shall I write this as minus half gt square? Are you with me? Okay, then what do we know about, now you can see here, the displacement moved by particle P and the displacement moved by particle Q. What happens? They are, I mean, you can see that SP and SQ both together cover how much of the distance? Both of them together gives you this height capital H, right? So do you agree if I write like this, SP plus SQ, SP plus SQ is equal to capital H, because you get the displacement of P, and if you have the displacement of Q, it adds together to give you the total, the greatest height, capital H, right? Okay, so input the values. So SP is half gt square, SQ is half ut minus half gt square. Do you agree with me? It's equal to capital H. So what happens here? Plus half gt square minus half gt square cancels out. And you end up getting here half capital ut, half ut equals to h. Are you with me? Half ut equals to h. Now what are we supposed to find? We are supposed to find t. Find in terms of u and g the time. So you are supposed to find in terms of u and g this time. You have to make t the subject. How do you make t the subject? Now you can see I have t here in terms of u and h. So they tell us to get the answer for t in terms of u and g. How do I get rid of the h? So didn't we get the substitution for h in part A? Who is h? H is u square over 2g. So substitute from part A, half ut equals, instead of h I use u square over 2g. Are you with me? Now make t the subject. So when you make t the subject, I get here u square over 2g times the half, the 2 comes up and the u goes down. Can you see? So what am I getting? T equals, u and u cancels, 1 u is remaining on top, 2 and 2 cancels, so you get t equals to u over g. So the time taken is u over g. The time taken to move from the point where Q is projected to the point where the particles collide, or the time taken to move from the greatest height of P to the point where the particles collide. That time is capital U over G. Okay, is this clear? Okay, so next part they say in part C, find where the two particles collide. Okay, so how do you find the place where the two particles collide? Obviously, we will try to find SQ. SQ is okay, right? Because the displacement Q is the displacement of Q above the ground when the two particles collide. SP gives the displacement of P from the highest point. So it's better that we find SQ, right? Are you with me? Because then we find the displacement from the ground. Okay, how much of a distance above the ground are you colliding? So let's find SQ. So I already have an equation for SQ. Can you see? Shall I do part C over here? Part C, what is SQ? SQ is equal to half ut minus half gt square. Okay, then shall we input the values that we found? Now we found the t value, right? Half u, what is the t value we found? T is capital U over G. Can you see? So replace T with U over G. Over here also I have minus half G T square. So T is U over G. T square will be U square over G square. Because T is U over G, T square is U square over G square. Simplify, I get here half U square over G. Do you agree? Or in other words, shall I write U square over 2G? Same thing, right? In here, minus a G will cancel out. Can you see one G term will cancel? And I get on top U square over the 2 and G multiplies 2G. So U square over 2G minus U square over 2G gives me 0. So displacement of Q above the ground when the particles collide is 0. What does that tell you? What does that tell you? Displacement of Q above the ground is 0 means? That means that from 0 means the particle is at the ground, which means what? Particle Q is going to, now you are projecting it up. Then how come you are colliding at displacement Q 0? It means the particle Q will go up with speed half U and come back down. And when it's coming back, the other particle is on its way down and both of them will collide at the exact same time. They both will collide at the exact same time when both of them are coming towards the ground at this point. They are both colliding when they are coming down. So P comes all the way down to here to collide with Q because Q comes up and comes down. So at this point, so they both collide at exactly when they both reach the ground. That's why you get 0 here. I hope you can understand that. Okay, is that okay? Okay, so again if I say now particle Q, now you get the displacement of Q to be 0 at the point where the particles collide because S cube is supposed to be the displacement of Q above the ground where the particles collide. But you can see it's becoming 0. So how come it's becoming 0? It's becoming 0 because not because the particle Q is staying at O all the time, right? No, you know it's being projected up. So it's being projected up and then it goes a certain distance and then it again comes, it returns back. So the moment it returns back to O, that's the same time when P comes to O. So that's why they both collide at the point O. Okay, so they do not collide mid-air over here. Okay, so if you put this to SP, what happens? Okay, there's a question. What happens if you put the T value to SP? What happens if you put the T value to SP? You will get a different answer. Yes, that will be different because the SP is measured from the greatest height, from above, from this point. So if you get SP, I think you will get the answer as what? If you, you get U square over 2G. U square over 2G is H. So makes sense, right? U square over 2G is H means because from point P, you collide at a distance H meter below P. That is at the point O. Isn't it? Because if you replace T as U over G, you get here, when you simplify, you will get SP is U square over 2G. Who is U square over 2G? U square over 2G is capital H. So capital H means this particle P and Q collides at a distance H below P. H below P means at the point O. Okay? So whatever you use, you need to have an idea of what's going on here. So then they are asking you find where the two particles collide. So give the answer. You don't need to do any of those things. Just say the two particles collide. The particles collide at point O. The particles collide at point O, or the particles collide at the point of projection. Understood? So this is the answer. Okay? Question number 4. Two identical small rings A and B, each of mass M, are threaded onto a rough horizontal wire. The rings are connected by a light inextensible string. Okay? So there are two identical small rings A and B. You can see they are threaded into a rough horizontal wire. So this wire is rough, which means you will have friction. The rings are connected by a light inextensible string. A particle C of mass 3m is attached at the midpoint of the string. The particle C hangs in equilibrium below the wire with BAC equals beta as shown in figure 2. So you can see it's symmetric. By considering particle C, okay, sorry, the tension in each of the part AC and BC of the string is T. Okay, they tell you the tension in each part is T. Are you with me? They are telling you here the tension in each part is T. By considering the particle C, they are asking you to consider only C. Find T in terms of M, G and beta. Okay, so first things first, let's mark all the forces surrounding particle C. What are all the forces surrounding particle C? First thing we have is the weight. So we have 3 mg weight. What else do we have? Particle C is attached by the two parts of the string. So you have tension, and they have told you tension in both parts of the string is T equally. They say tension in both parts of the string AC and BC is T. Do you agree with me? So I mark T here. How do I get beta into this story? How do I get beta into this story? So can you see? I can get beta in here by using alternate angles. Okay, so I will use beta here. Can you see? So now what I will do is I will consider all the forces only acting around particle C. So consider particle C individually. Okay, so when you consider particle C individually, consider the horizontal equilibrium and vertical equilibrium. So it's not vertical, it's not horizontal that works here. We'll go with the vertical equilibrium. So what are the upward forces? Yeah? So you have to resolve the tension, right? So what are the upward forces? T sine beta. Can you see? Upwards we have T sine beta. This guy also resolves to give T sine beta, and here this T also resolves away from the angle to give T sine beta. Can you see? So T sine beta from here away from the angle, and this guy another T sine beta gives you how much? 2T sine beta. When you add T sine beta plus T sine beta is 2T sine beta. Okay, so that will be equal to what? Now that's the total upward force. So this is balancing out with whom? The downward force is 3 mg. Because we are considering the vertical equilibrium of particle C individually. Okay, consider particle C individually, this system individually. Okay, that system, all the forces must be in balance for particle C to be in equilibrium. Okay, so then I get here, they ask you to get the answer in terms of beta. So tension equals 3 mg divided by 2 sine beta. Do you agree? Is this clear? Okay, so moving on to part B, they say find in terms of M and G the magnitude of the normal reaction between the wire and A. Okay, so now where do we need to consider? We have to get the magnitude of the normal reaction between wire and A. So now we will consider the ring at A, and we will now consider this system and consider individually what are all the forces acting on this particular system. Okay, so what are the forces acting on this system? Particle A has a weight. Can you see? Mass is M. So the ring A. So then let's mark the weight of the ring, which is mg. What else do we have? You can see you have a string here. So if you have tension T here, you know there's an equal opposite tension on the other side. Do you agree with me? So you have an equal opposite tension on the other side here, T. Do you agree? What else do we have? So this we have the normal reaction here, right? So upwards you have the normal reaction. And now what else do we have? There's another force to be considered here. They do say that this wire is rough. So if the wire is rough, I'm drawing these lines to say the wire is rough. Now when the particle C, now you know a ring means it has the capability of moving on this wire. Isn't it? A ring means it can move left, right along the wire. So when you attach this particle C, because of the weight, to which direction do you think this string is more inclined to move? With the weight pulling downwards, the ring is inclined to move to the right side. Can you see? The ring at A. The ring at A is inclined to move towards the right side because the weight is pulling down. The ring at B is inclined to move towards the left side. Do you see that? So now I'm only considering about ring A. So because of the weight, the tension pulling it this way, the ring is if it is to move, it will try to move to the right side, isn't it? So then friction is the resistive force. We'll try to oppose that, which means the friction acting here must act in which direction? Must act in the opposite direction. Do you agree with me? So they do not use the word the limiting equilibrium here, so you don't have to go for F max. Just mark a resistive force or a friction force. Do you get what I'm saying here? Okay. So I'm going to consider now again the individual system around ring A. Consider the individual system of forces around ring A. Okay, you don't have to get the whole system involved here. You can get it involved, but it's easier to go with individual forces around ring A. Are you with me? They are asking you to find in terms of mg the magnitude of the normal reaction between wire and A. Okay, how do we get the normal reaction? The first thing is, do you realize your tension, now your normal reaction mg is the vertical direction, friction is horizontal direction, but your tension is in the inclined direction. So you have to resolve the tension, right? The first thing. So what happens when you resolve the tension? What do you get? Towards the angle you get here T cos beta, away from the angle downwards, can you see you get T sin beta? So I marked it downwards because it acts along the direction of mg downwards. So mg plus the T sin beta, because T sin beta comes down. When you resolve away from the angle, the arrow is pointed down. Okay, so now I don't need to work with this tension, so I can work with the horizontal and vertical equilibrium. So now what do we do? For part B, we can go for the vertical equilibrium of ring A. So by using the vertical equilibrium, what do we get? Normal reaction upwards must be equal to mg plus the T sin beta. Do you agree? This normal reaction upwards is equivalent to mg plus T sin beta. The horizontal forces make no impact whatsoever on vertical system. You know that perpendicular forces do not make any impact. So only these the upward forces must be in balance with the down forces to be in equilibrium. Do you get me? So they want us to get the answer in terms of m and g, right? So I think we found the value of t in part A. Shall we substitute? R equals mg plus tension is what? Tension answer in part A is 3 mg over 2 sin beta. Do you agree? 3 mg over 2 sin beta into there is a sin beta. Because it's tension times the sin beta. Can you see what happens here? So we don't have to find sin beta here because sin beta will automatically cancel. So you get here normal reaction equals to mg plus 3 mg, which gives you normal reaction equals 4 mg. Do you agree with me? Normal reaction equals to 4 mg. Okay. Then we'll go to the next part. The coefficient of friction between each ring and wire is 4 over 5. Okay, they have given you the mu value. Okay. Oh, sorry, there is no 2 here. Sorry. Mg plus 3 mg over 2. Sorry, yes. The 2 doesn't cancel out here, right? Yeah. Mg plus 3 mg over 2 is how much? 5 mg over 2, right? Yeah. So R equals 2.5 mg or 5 over 2 mg. Okay. Part C. The coefficient of friction between each ring and the wire is 4 over 5. Coefficient of friction means they are giving you what value? The mu value. They say the two rings A and B are on the point of sliding along the wire towards each other. I think we figured this out anyway, right? In the earlier part, I told you that if this weight is pulling down, the rings are going to move towards each other, which means the friction will oppose, isn't it? Find the value of tan beta. How do we get the value of tan beta? So you don't need to go to the ring B here. We can again go with ring A. In ring A, we considered vertical equilibrium. So what's the other thing to consider? Now we can consider horizontal equilibrium, and they do say that it's on the point of sliding. So if it's on the point of sliding, what equilibrium do we have now? Point of sliding means you have what equilibrium? We use a specific word. When it's on the point of sliding, we have limiting equilibrium, which means what friction do we have here? Do we have the normal friction? No, we have the maximum friction, which means the what friction? You have the mu r friction. If you are on the point of moving, then you have the maximum friction. So then for particle A, you can consider the horizontal equilibrium now. T cos beta must be equal to F max. Are you with me? So tension cos beta is equal, F max is mu r. So right now we found the tension value, we found the normal reaction, we know mu. Let's substitute everything and we should be able to find tan beta. So what's the tension value? Tension value we found in part A. What was it? 3 mg over 2 sin beta multiplied by cos beta equals mu is 4 over 5, right? into normal reaction. How much is normal reaction? We just found in part B. Normal reaction of the ring at A is 5 mg over 2. Can you see? Okay, so now it's a matter of simplifying and getting the answer. So I get here, shall I cancel off the mg? Both the sides I have a mg. So I get here 3 over 2 cos beta over sine beta. I get here, can I cancel off? I can cancel off 5 and 5, right? And 4 and 2 cancels out to give 4 divided by 2 is a 2. Then shall I get cos over sine? I mean sine over cos is tan, not cos over sine. So shall I take these two terms to the other side? 3 over 2 equals 2 times sine beta over cos beta, which gives me sine beta over cos beta is tan beta. I'll bring the 2 to the other side as a division. So 3, 2 multiplies with 2 to give 4. 3 over 4 is equal to tan beta. This is what they want. Are they asking us to find the beta value? No, they ask us to find the tan beta value. So this is the value of tan beta. Simplest form. So find the value of tan beta. You don't have to go for tan inverse. Okay, so is this clear? Okay, question number 5. A car travels at a constant speed of 40 meters per second in a straight line along a horizontal racetrack. At time t equals 0, the car passes a motorcyclist who is at rest. The motorcyclist immediately sets off to catch up with the car. Okay, so what's happening here? So first you have a car which is traveling at a constant speed of 40. At time 0, the car passes a motorcyclist who is at rest. So at time 0, that means the car is having a constant speed of 40. So at time 0, motorcyclist is at rest. The motorcyclist immediately sets off to catch up with the car. The motorcyclist accelerates at 4 meters per second square for 15 seconds and then accelerates at 1 meter per second square for a further t seconds until he catches up with the car. Now, do you see visually what's going on here inside your head? So at the time when this is starting, the car is having initial velocity, right? The car is already traveling at 40 meters per second speed, while the motorcyclist is completely at rest, isn't it? So the motorcyclist is completely at rest, which means at time 0, when from time 0, the car is moving at constant speed 40, while the motorcyclist has to start from the 0 velocity and has to obviously the car will pass the motorcyclist and go. So the motorcyclist has to kind of like race behind the car, and then when it catches up, what do you mean by catching up? What will be equal when they catch up with each other? When the motorcyclist is actually going to come to the same point as the car, the distance travel from the starting point, the distance travel will be equal when they catch up with each other. Okay, so they ask you to what? Sketch on the same axis the speed time graph for the motion of the car and the speed time graph for the motion of the motorcyclist from time t equals 0 to the instant when the motorcyclist catches up with the car. Okay, so let's quickly draw a speed time sketch. So this is the so speed time. Speed in meters per second and time in seconds. Okay, so they say here a car travels at a constant speed of 40, which means for the car, you can draw a direct straight line, right? Just draw this horizontal line. Are you with me? And this is how much? This is 40 meters per second. Speed in meters per second. Time in seconds. Okay, and then what about the motorcyclist? The motorcyclist accelerates at 4 meters per second square for 15 seconds. Okay, he accelerates at 4 meters per second square for 15 seconds. Okay, so when you are drawing the graph, okay, so then you need to decide now, this is of course acceleration means you have a gradient. Okay, so now you need to kind of make a decision at the end of the 15 seconds. Is the motorcyclist going to be having a velocity more than 40 or less than 40? Okay, so what do you think of that value there? You can use V equals U plus AT, right? So initially he's at 0, acceleration is 4 meters per second square for 15 seconds, which means how much? How much is it? How much? 60 meters per second. So you can see at the end of the 15-second time gap, the motorcyclist has accelerated to a speed of 60. Okay, so that value is actually not required, the 60, they just want to see the shape of the graph. Okay, so I just did an extra calculation to ensure that the graph is moving up or down. Okay, so the motorcyclist at 15 seconds reaches a speed of 60, which means we know it's above the 40. So now the motorcyclist at the end of 15 seconds has actually, now does this mean that the motorcyclist is passing the car? At this point, what does it mean? Now, a common mistake some people think is at this point the motorcyclist catches up with the car. No, this is the point where the motorcyclist catches up with the speed. The speed of the motorcyclist and car are equal at this particular point, but that doesn't mean the motorcyclist is ahead of the car at the same point as the car, because the areas, if you consider the area traveled by the car and the area traveled by the motorcyclist, you can see the area of the motorcyclist is this small triangle, while the car is this entire rectangle. Okay, so the area of the car is higher. So then when it catches up, the areas must be equal, not the times, not the place where the lines intersect. When the lines intersect, the speeds are equal. And then after coming to this point, they say the motorcyclist accelerates at 4 meters per second square for 15 seconds and then accelerates at 1 meter per second square, which means the slope should be what? Higher or smaller? Acceleration is the gradient, right? So acceleration of 1 meter per second square means definitely your gradient should be considerably lower. Okay, so 1 meter per second square for a further t seconds. So for a further time of t seconds, you are the motorcyclist is accelerating. Are you with me? And then they say until he catches up with the car. So what is this t second time? So this is the place he catches up. So I can remove this part of the graph. So at this point, what happens? At this point, the areas under the distance traveled by the bike and the area of the graph under for the distance traveled by the car must be equal. That's how they catch up. Okay, now my question is, where do I mark T? Do I mark capital T here? No, they say capital T is what? He accelerates, the motorcyclist accelerates at 1 meter per second square for a further capital T seconds. So capital T seconds is only this time gap. Are you with me? Which means only this time gap is capital T, which means this value is 15 plus T. This value is 15 plus T. Okay? Okay, so this is our speed time graph, part A. Okay, so I have done some extra things here, but this is not required. But so this is the speed time graph. You must mark 15 and the 15 plus T and the 40. Okay, then they say at the instant when T equal T1 seconds, the car and the motorcyclist are moving at the same speed. So which point are we talking about? Where is T1? I was just mentioning about this in part A. T equal T1, the car and motorcyclist are moving at the same speed. So same speed is where the lines intersect. So this is the T1. Okay, so they are asking you to find the value of T1. How do I get the value of T1? Okay, how do I find the value of T1? What do we use? So you can see here, we obviously know the we obviously know the speed that will become the same, right? Now you can see the car is traveling at a constant speed of 40. So when the motorcyclist and car are traveling at the same speed, it means the motorcyclist has come up to the speed 40, isn't it? So how can I find the time taken? Considering the motorcyclist, we can again apply what? V equals U plus AT to the motorcyclist. Okay, so we can apply V to the motorcyclist. So what happens here? Final speed is, so when the speeds are equal, the final speed is what I'm considering the graph only for this part of the graph. Can you see? Only this part of the graph. So final speed of the motorcyclist will be 40. Starting speed is 0. Acceleration is, at the initial part, they said the acceleration is 4. Time taken to move that particular part is T1. So T1 equals 40 divided by 4, which is 10. Are you with me? So T1 is 10 seconds. Is this clear? Okay. Then they say in part C, show that t square plus kt minus 300 equals 0, where k is a constant to be found. Okay, how do I get this inequality? Now how do I get this quadratic equation? There's 6 marks here. How do we get this? Obviously, what's the next thing that's remaining for us to do? The areas under the graphs must be equal, isn't it? The areas under the graphs must be equal. So the distance traveled by car. So distance traveled by car. Let's find it. What's the distance traveled by car? So it's the area of this rectangle, right? Can I know the area of this rectangle? Length into breadth. How much is the length? How much is the breadth? For this rectangle, how much is the length and how much is the breadth? 40 into, how much is the breadth here? This distance. This is t plus 15. 15 plus t is this value, right? This full length. So what about the distance traveled by motorcyclist? So what about the distance traveled by the motorcyclist? So for the motorcyclist, do we have a standard shape for this graph immediately? No, right? So this is not a trapezium. So you will have to go with what? You will first have to go with the area of the triangle and then you will have to go with the area of the trapezium. Can you see? When it comes to the motorcyclist, we will have to consider his area under two sections. So area of the triangle, area of the triangle separately and area of the trapezium separately. Can you see? Shall we get those two values? So how do we find it? Area of the triangle is half into base into height, half into, how much is the base? How much is the base? 15 into how much is the height? 60. So I have already found it. Plus for the trapezium. So for the trapezium, I have to use half a plus b into h. So do we know the values half a plus b into h? I need to know this velocity here, isn't it? How do I get the velocity here? Because I need this for the length of the parallel lines, I need this height. So they have told us the acceleration here is 1 meter per second square, right? The gradient. So we can again use from this point to this point, what can we use? We can use v equals u plus at from this point to this point. So what do I get? Final velocity is what I am trying to find. V is what I am trying to find over here. Do you agree with me? This v is what I am trying to find. Initial u is where we start. We start at 60. Acceleration is 1 into time taken is capital T, because the time taken for this time duration is capital T. Are you with me? So velocity is 60 plus t. Do you agree? So this speed here is 60 plus t. Do you agree with me? Okay, is this clear? We use v equal u plus at for this section of the graph. Okay, so then I found this velocity value here is 60 plus t. So now I can go for the area of the trapezium. What's the area of the trapezium? Half a plus b is the sum of the two parallel lines. So what are the two parallel lines here? Who are your two parallel lines? Can you see? These two are the parallel lines. So what is the sum of the lengths of the parallel lines? 60 and 60 plus t, right? Into how much is the perpendicular distance between them? Between the two parallel lines, perpendicular distance is capital T. Is this clear? So shall we simplify this a little bit to make it easier? Because at the end of the day, to get this quadratic equation, I just have to equate the distances. The distance traveled by car and the distance traveled by motorcyclist. However, it would be easy if we simplify. Half into 15 into 60. How much is it? Half into 15 into 60. How much is it? 450. Plus this one, half into 60 plus 60 is 120 plus t times capital T. So that's the maximum we can simplify, right? So shall we equate these values now? So distance by car is equal to the distance traveled by motorcyclist. So distance traveled by car is 40 times 15 plus t, while the distance traveled by motorcyclist is 450 plus half into 120 plus t times capital T. Are you with me? Shall we open the bracket? 40 times 15 is, open this bracket here. 40 times 15 is, yeah, how much? 600 plus 40 into t is 40t. Equals, this is 450 plus half into 120. So in this case, the bracket opens. Is it just with the half the bracket opens? No, half and the t both contribute towards opening the bracket. Half into 120 into t is 60 capital T. And the next bracket when you open, it's both the half times t and the, because outside the bracket we have two of these numbers, so both of them multiply inside, right? Or else you could have taken the capital T in front here and taken half t directly together and open the bracket. So it's the same thing. Half t into t is half t square. Are you with me? Shall we simplify? Let's take the like terms to the same side. So I get here 0 equals half t square. Simplify the like terms. Plus 60t and the plus 40. So when you bring the plus 40t here, 60 minus 40t is plus 20t. And then in here, the constants, when you simplify, plus 450, that plus 600 comes over here as minus 600. 450 minus 600 is minus 150. So in the show that, I think they have given you an equation with just simply with t square. There's no half t square. So multiply the whole equation with 2. So 0 equals t square plus 40t minus 150 times 2 is 300. Can you see? Okay, so this is the show that. So what's the k value? They have told you to find the k value, where k is a constant to be found. So t square plus kt minus 300 equals 0. So we got t square plus 40t minus 300, which means your k value is 40. So can you see we got the show that? Okay. Okay, question number 6. A force F is given by F equal 10I plus J Newton. Find the exact value of the magnitude of F. How do you get the magnitude? So you square the I component and you square the J component and you square root. Is that correct? Okay, to get the magnitude. So 10 square 100 plus 1 is 1. So it's root 101 newtons. Is that correct? Okay, so magnitude of force F is root 101 newtons. Do you agree with me? Part B, they say find in degrees the size of the angle between the direction of F and the direction of the vector I plus J. So direction of, you need to find the size of the angle between the direction of F. F is 10I plus J and the direction of the vector I plus J. So you have to, what you need to do here is mark them both in what? Mark them both in a single diagram. Are you with me? Mark them both on a single diagram. Okay, so the first one is F is 10I plus J. So 10I plus 1J, which means on the x axis, on the I axis it's 10 units. On the J axis it's 1 unit, isn't it? So this is force F. Are you with me? This is force F. Are you with me? And then the other angle you have to mark is I plus J. I plus J is 1, 1, right? Which means it's over here. So which means the angle you consider is over here. Are you with me? So you are supposed to find what? The angle between these two. How do we get the angle between these two? How do you get the angle between these two? First, you can find the large angle between I plus J. So this is I plus J. This is the 10I plus J. Okay, how do we get the angle? So I plus J, I think you can see when both are 1 and 1, this angle is definitely going to be how much? The theta angle. is definitely going to be opposite over adjacent 1 over 1, tan inverse 1. It's going to be 45 degrees. Are you with me? Then let's mark the other angle. I'll mark this small angle as alpha. How much is tan alpha? Opposite over adjacent. Opposite is 1, adjacent is 10. Do you agree with me? So alpha is tan inverse 1 over 10. And you can get the answer. And then they wanted to find the angle between these two. So what is the angle between these two? Between angle is what I'm coloring over here. Can you see? This colored angle, isn't it the between angle? When you consider the angle between f and I plus j, isn't this colored angle the angle in between? How do you get that angle? How do you get that angle? Angle that you require here is from theta, you should subtract the alpha. So theta is 45. Subtract the alpha, tan inverse 1 over 10. Can I know the answer? How they want this correct to find in degrees, the size of the angle. So how much is it? 39.2. Yeah, keep going. 289. So it goes on like this, right? So to 3SF, 39.3. Okay, is this clear? Okay. Then they say here, the resultant of the force, okay, in part C, the resultant of the force F and the force minus 15I plus AJ, where A is a constant, is parallel to, but in the opposite direction to the vector 2I minus 3J. Okay, so how does this work? Okay, so they are saying the resultant. How do you get the resultant of two forces? How do you get the resultant of two given forces? You have to add the given forces, right? If you to take the resultant, you must add. So the resultant of the force F and the force minus 15I plus AJ. So the resultant is when you add. So this resultant is what? Is parallel but in the opposite direction means what? What do you mean by the opposite direction of 2I minus 3J? So opposite direction means how do you take the opposite direction? Okay, so opposite direction means to change the direction to the other side, the reverse direction, what do you have to do? You have to just take the negative of the same person, isn't it? So this F plus the resultant force is parallel to minus of, because it's the opposite direction, minus 2y minus 3j. Are you with me? So we get here F plus minus 15I plus AJ is parallel. So I have told you to remove the parallel to put a constant. To put the equal sign, you put a constant. So here we will put minus lambda times 2y minus 3j. This is how you remove the parallel. To remove the parallel, just input a constant. Just input a constant. So F value is known, right? We actually know F. F is 10I plus j. Shall we replace F with 10I plus j? Okay, so this is all you have to do. Okay, so the opposite, I hope you understood by opposite, I took the opposite sign here. That's why I put a negative sign outside. To remove the parallel, I put a constant. So now what do we need to do? After you come to this step, always what we do is we compare coefficients. You compare coefficients for your I vector and j vector. So compare coefficients for the I vector. What are the coefficients with I? So you have, what do we have here? 10I, and you have minus 15I, and you have, can you see, 2 into minus lambda. So let's write everything down. What are the coefficients of I on the left side? So 10, I'm not writing the I because I'm just taking the coefficient 10, and here I get plus into minus is minus 15I. So that's just writing the minus 15. So this is equal. On the other side I get minus 2 lambda. Are you all with me? So I get here how much? 10 minus 15 is minus 5 equals minus 2 lambda, which gives me lambda is plus 5 over 2. Minus divided by minus is plus. Do you agree with me? So lambda is a constant that we input, so it's not lambda that we are supposed to find. We are supposed to find the value of A. Now let's compare the coefficients for whom? For J. So what are the coefficients of J? Simply J here means it's 1J. Are you aware of it? So take the coefficients. So I get here 1J. Here AJ, and here minus lambda into minus 3j, so plus 3 lambda j. Can you see? Shall we compare? What do we get here? 1j, so that's just 1 plus aj is just a equals on the other side I get minus lambda into minus 3 is plus 3 lambda. Are you with me? So we can substitute the value of lambda since we found it. So 3 times 5 over 2. Get the a value. A is 3 times 5 over 2 is 15 over 2 minus 1. How much is 15 over 2 minus 1? A is 13 over 2, or in other words 6.5. Okay, so 13 over 2, or in other words it is 6.5. Okay, is this clear? Okay, question number 7. A particle A of mass 4 kg is held at rest on a rough horizontal table. Okay, so for rough, I will just mark like this to say it is rough so that I will not forget. Particle A is attached to one end of a string that passes over a pulley P. The pulley is fixed at the edge of a table. The other end of the string is attached to a particle B of mass 3 kg, which hangs freely below P. Okay, particle B is hanging freely while particle A is on the rough horizontal table. The part of the string from A to P is perpendicular to the edge of the table, and A, P, B all lie on the same vertical plane. Okay. The string is modeled as being light and inextensible, and the pulley is modeled as being small, smooth and light. Okay. So all these modeling assumptions are explained in the textbook, right? In chapter 1. Okay. So they say the system is released from rest with the string taut. At the instant of release, A is 2 meters from the edge of the table. Okay, A is 2 meters from the edge of the table and B is 1.4 meter above a horizontal flow as shown in figure 3. After descending with constant acceleration for 2 seconds, B hits the floor and does not rebound. Show that the acceleration of A before B hits the floor is 0.7 meter per second square, and this is simply how many marks? 2 marks. Okay, how do we do part A? So they have told you the time taken for B to hit the floor is how many seconds? It just takes only 2 seconds. It just takes 2 seconds to travel how much of a distance? 2 seconds to travel a distance of 1.4 meters. So how can I mean, do we need to go for marking forces and doing F equal ma here? No, so we can directly go with what equation? The starting velocity is 0 here. Isn't it? It starts at rest. What equation can I use to get the acceleration here? Is it V equal U plus AT? No, we know this will come and hit the ground at a certain speed. So we do not know the V value. So don't go with V equal U plus AT. Is it V square equal U square plus 2AS? No, because we do not know V again and we do not know A. So the equation is S equals UT plus half AT square. I am applying it to B and downward direction. So downward displacement of B is 1.4. Starting speed is 0. So U is 0. Half into acceleration is what I am trying to find. Time is 2 seconds. So T square means 2 square is 4. So 1.4 equals half into 4 is 2A. So which gives me acceleration is 1.4 divided by 2 is 1.4 divided by 2 is 0.7 meter per second square. Is this clear? Then the next part they say state which modeling assumption you have used in order to answer part A. So what modeling assumption did we use to answer part A? Now what is the main modeling assumption that we use here when the particles are traveling? We say what? Now we found the acceleration here, right? So in part A we did the acceleration. So for the acceleration in this kind of a system, there is a very specific modeling assumption you have to use. So in the table, in the M1 book chapter 1, in the table, there is a modeling assumption where we say the acceleration of both sides of the string is equal. That happens when they use the word when the string is inextensible. Now do you see here they use the word the string is modeled. They are asking from all these modeling assumptions which one did we use? The string is modeled as being light, inextensible, and the pulley is modeled as being small, smooth and light. Can you see these are the modeling assumptions that we have taken? So they are asking out of all of this for the acceleration, which one is which of these do we have to use? So these are all the modeling assumptions that we have taken. So out of all of this, which one is the one that is relevant for the acceleration? The one that is relevant for the acceleration is the one where they talk about the string being inextensible. Okay, so go to the M1 book. In the table, you will see for the string being inextensible, they say the acceleration is equal at both ends of the string. Okay, so that is there in your M1 book. Part B, so you can say inextensibility of the string. That is the modeling assumption that we have used from this particular section. Then the next one, part C, find the magnitude of the resultant force exerted on the pulley by the string. Okay, they are asking you to find the resultant force on the pulley. Okay, so how do we get the resultant force on the pulley? So what are the forces acting on the pulley first of all? What are the forces acting on the pulley? So first of all, let's start with the forces. Let's mark the force diagram. Starting with particle B. What are the forces acting on B? The weight. Let me make the diagram bigger. So we have the weight. And then we have the tension. Equal opposite tension acts on the pulley, right? Can you see? And since the pulley is smooth, the tension in this side is equal to the tension on the other side. Can you see? The pulley is smooth, so does it have any weight? No, they say the pulley is smooth and it's light, so there is no weight. And then the equal tension again comes over here. Do you agree with me? Yeah, the same tension, this tension is here, the same tension comes here and it comes here. Okay, and then what else do we have? At the point A, we have the mass 4 kilogram. So weight is 4 g. And then we have the normal reaction. And we also have what? Since the object, now you do realize this particle is moving, accelerating downwards, thereby particle A is accelerating to the right, which means the friction, you know, it's a rough table. See, I have marked it to mention that it is rough, which means friction is acting in the opposing direction. Okay, is this clear? Okay, so then they are asking you to find in part B, state in part C, find the magnitude of the resultant force exerted on the pulley by the string. So what are the forces acting on the pulley? Let's consider the system of the pulley. So this is the pulley system. What are the forces acting on our pulley? The two tensions, right? One tension to the left and the other tension directly acting down. So the thing is, first we have to get this tension value. How can I get the tension value? So obviously we will be applying what? F equals ma. So I'll apply F equal ma to whom? We can easily work for F equal ma with particle A or B. Particle B, because you can see in particle A we have friction. There are unknown forces. So let's go to particle B and apply F equals ma. Are you with me? So let's apply F equals ma to particle B, and I'm going to apply it downwards because particle B is moving downwards. So what are the forces? Sorry, this is not 3 mg, this is 3g, right? Okay, so particle left downward, it's 3g minus tension. Okay, 3g is acting down, tension is acting up. So applying to forces acting on particle B. So only T and 3g are the forces acting on particle B. So this resultant is equal to mass is 3 kilogram. Acceleration you just found as 0.7. Do you agree with me? Okay, how much is the answer? So 3g minus 3 into 0.7 is equal to tension. Do you agree with me? How much is the tension? 3 into 9.8 minus 3 into 0.7 is? How much? 30? How much is the tension? 3 into 9.8 minus 3 into 0.7. Okay, 27.3. Okay, so this is the tension value. Now bear in mind we use G as 9.8, so final answers must be given to 2SF or 3SF. So this is not a final answer, so take full figures here for now. And the final answer that we are finding here is what? The magnitude of the resultant force exerted on the pulley. Okay, so let's consider the pulley. So how do I get the resultant force on the pulley? So if you consider the pulley system, you can see pulley has the x direction force is tension, y direction is also the tension, right, downwards. So normally to get the resultant of a certain particle, what do? We take the sum of forces in the x direction, square it, and we take the sum of forces in the y direction, square it, and we square root. Do you see? So in here, what is the sum of forces in the x direction for the pulley? Now, do you realize that none of these tensions make any impact on each other because they are perpendicular? So do we need to resolve or do any extra work here? No. So the sum of forces for the pulley in the x direction is T. So T square. Are you with me? See, T square plus sum of forces in the y direction is also T. So you have to square T square. So now let's input the T value and final answer must be given to 2SF or 3SF since we use G as 9.8 inside the sum. Okay, so how much is it? 27.3 square plus 27.3 square root. I hope all of you were clear with what I did here. Were you clear with this part? The x direction, y direction, sum of squares and square roots. So that is 38.6080. You get it, but you must give your answer to either 2SF or 3SF. So 38.6 Newton or 39 Newton. Even 39 Newton is okay. 3SF or 2SF because we use G as 9.8. Is this clear? Then moving to the next part. So the majority of the marks is given here. The coefficient of friction between A and the table is mu. Find the value of mu. Okay, how do I get the value of mu? So obviously now I know the acceleration. Okay, we know the acceleration, we know the tension. How do I get the mu value? So what are we going to use? We are going to use for part D, right? This is in part D. I'm going to use what? F equals ma to particle A. Are you with me? I'm going to use F equals ma to particle A in which direction? To the right direction. So what are the forces acting to the right? So consider the forces acting only on particle A now, okay? So what do we have? Tension opposing friction equals mass is 4 into acceleration is 0.7. Are you with me? Okay, tension value we just found. What was it? 27.3 minus, now here actually friction means, you have the maximum friction here. Why? This is not the normal friction. This is the F max friction. Why is it F max? Because the object is moving. If your object is moving, you have the maximum friction. First, let's get the F max value. 4 into 0.7 is 2.8, right? Can you all get me the F max friction? 27.3 minus 2.8. How much is it? 20? So F max is 24.5. Now, for F max, we use the equation. What is it? F max is equal to mu r. So F max is 24.5. Mu is what we are trying to find. Normal reaction will be equal to what in this case? Direct normal reaction is equal to 4g. So get the mu value. So mu equals 24.5 divided by 4 times 9.8. G is, you had used G as 9.8, not 9.81. Okay, how much is it? Mu, and in this case also mu value must be given to how many SF? Either 2SF or 3SF, 0.625. Okay, I think you directly get 0.625 exactly, right? Okay, so you can even leave your answer 0.63. Okay, so that is also an acceptable correct answer. Is this clear? Okay, that's the answer for part D. So we'll move to the last part. They say part E, determined by calculation whether or not A reaches the pulley. Okay, what do you mean by that? You had determined by calculation whether or not A reaches the pulley. What do you mean whether A reaches the pulley? Okay, so how do we find whether A reaches the pulley? Okay, so now I brought a copy of the diagram down here. Now the question is determined by calculation whether or not A reaches the pulley. Okay, now the first thing is you realize at the start A and B were at these positions. So B traveled a distance 1.4 meter down, right? So when B travels a distance 1.4 meters down, what happens to A? A travels a distance 1.4 horizontally. Do you agree with me? A travels a distance 1.4 meter horizontally. So let's say A comes over here now. So this is the particle A. Okay, now the thing is while A is traveling this 1.4 meters, the question is it traveling this 1.4 meter in a constant speed? Now we found that there is acceleration involved here, isn't it? So particle B moves down with an acceleration. Particle A moves horizontally with that same magnitude of acceleration, isn't it? So thereby, when the particle A comes to this point, is it coming here with a decreasing? I mean, how does it come? It comes here obviously by increasing its speed, isn't it? It started at speed 0, and when it has traveled a 1.4 meter, definitely your particle A will achieve a certain velocity. Do you agree with me? So that velocity that particle A achieves at this point, that velocity, and what do you think about the velocity that particle B achieves? Now you know they are both traveling this 1.4 meter together under the same magnitude of acceleration. So the magnitude of velocities, will they be different? Since they are both traveling together with the same string, traveling the same amount of distance at the same amount of time, the particle B also has that same velocity after traveling 1.4 meters, isn't it? So can't you get that velocity first, the velocity with which B strikes the ground? Okay, that's the first thing to do here. Okay, calculate the velocity that B strikes the ground. I want you to find the velocity that B strikes the ground. How do I get that velocity? What equation do I use? What is the easiest equation to use here? Yes? Use V equals U plus AT. Use V equals U plus AT to whom? To A or to B? We will use it to particle B. We will use it to particle B. Okay, so downward, so velocity is 0. Final velocity is what I am trying to find, the velocity of striking the ground. Okay, initial velocity is 0. Actually, we can use it to anyone, right? A or B. Okay, acceleration is 0.7, time taken is 2 seconds. Okay, so you realize the time taken is 2 seconds. So even particle A will take 2 seconds to go from, to travel the 1.4 meters. Do you agree with me? Okay, so actually you can use V equal U plus AT to either A or B. It doesn't matter here. So can I know the velocity at which B strikes the ground? 0.7 into 2 is 1.4 meters per second. Do you agree with me? So B strikes the ground with 1.4 meters per second. At the same instant, A also has that same 1.4 meter per second speed. Are you with me? So when A strikes the ground, A is immediately brought to rest. But does that mean that, when B strikes the ground, B is immediately brought to rest. It doesn't rebound. They say in the question, it doesn't rebound, it comes to the ground, it immediately comes to rest. So what happens to particle A? Just because B comes to the ground and stops immediately, does it mean that A will immediately stop at this point? Definitely no. Why? Because A has achieved a certain velocity and A will continue to move forward. But now there is a difference in the motion. What's the difference in the motion? Previously we had this, the string supporting A was supporting the motion. We had this acceleration. The string was taut. Now A is not supporting the motion. B is not supporting the motion. B is on the ground. So B will not be pulling A anymore. Thereby now the string becomes slack because particle A will continue to move forward. But when it continues to move forward, now it will not feel what? That support in the tension. You will not have the tension in the string anymore. So the string will completely be slack. Are you with me? The string will completely be slack, and now particle A is going to travel forward under what? Will it accelerate anymore? Is it going to accelerate now? No. So what's going to happen? You will have to find the new acceleration. Actually, it will, wow, now what? It will start to decelerate because it will start to move forward and it will start to lose its velocity because you do not have the pulling force. The tension force is not there. What forces do we have at this point? What forces do we have at this point? Particle A is still feeling what? Is the friction going to be here or not? The tension is gone, but the friction is still there. That's the reason why this will decelerate. So you still have your F max friction. You still have the normal reaction. You still have the weight, but you don't have the forward, the tension force to pull this forward. Are you with me? So now let's calculate the new acceleration. The new acceleration of particle A after B hits the ground. Okay, so this is after B strikes the ground. You have to get the new acceleration of A. So how do we do that? What equation do we use? We must use F equals ma to particle A. So we'll apply, the particle A is moving forward. So apply F equal ma forward because particle A is moving forward. So is there any force that is supporting to move forward now? No. The only force we have to the horizontal direction is the friction that is acting to the other side. So minus F because it's acting backwards. No other horizontal forces are there. Mass is 4 kilograms and acceleration is what I'm trying to find because it's a new acceleration. So friction value we found, right? Mu r. So friction is the maximum friction. Mu r equals 4 into A. Mu value we found, right? What was our mu value? 0.625. Normal reaction is 4g, right? 4 into A, so you get acceleration equals minus 0.625 into 4g divided by 4. Can I have the new acceleration here? Minus 6.125. Is this correct? Minus 6.125. Okay, so you could leave your answer. Okay, our mu value was here. Okay, so remember this is not the final answer. Final answer must be kept to 2 or 3 SF. Okay, now we got the acceleration. Now what do we need to do? We need to decide under this new acceleration. Now you know there is how much of a distance is there until particle A to hit the pulley P. There is 0.6 meter that it needs to travel. So we have to see out of the 0.6 meters how much is it going to travel, whether will particle A hit the pulley or not. So you have to see how much of a distance your particle A will move under the new acceleration. You just found the new acceleration as minus 6.125. Okay, so shall we use what? We will use what equation? We know the final speed now. We know the particle, we need to find how much of a distance this particle moves until it comes to what? Rest, because you know the particle is decelerating. So we can use what? V square equals U square plus 2as for the new motion, for the new acceleration. Are you with me? Okay, so how much is this? V square is 0, U square is what? Is U square 0? No, U square is the place where you start the new acceleration. Where is the U square? You start the new acceleration with the starting speed is 1.4. This is the place where you start the new acceleration when the string becomes slack. When particle B hits the ground, that's where you start the new motion under the new deceleration, isn't it? So U is 1.4 square plus 2 into acceleration is minus 6.125 into displacement. So can I have the answer? This is plus 2 into 6.125 into displacement equal 1.4 square. How much is the displacement? 1.4 square divided by 2 into 6.125. How much is it? 0. Exactly 0.16. So this is the distance it moves forward. Now how much of a distance are we having here to until it strikes the pulley? 0.6. Okay. You have 0.6 here to until you hit the pulley, but the particle is only traveling 0.16. You only travel 0.16. Okay. So how much of a distance? So you can say total distance traveled by A. So we'll say like this, total distance traveled by A is how much? Initially particle A traveled how much? Because you know there's 2 meters from the place where A started until it hit the pulley. Initially it traveled 1.4 meter and now it traveled, initially it traveled, the total distance traveled by A is the 1.4 and now the 0.16. Altogether how much of a distance has it traveled? How much of a distance has particle A traveled? 1.4 plus 0.16 is how much? 1.56 meters. So this is, how do you determine whether it hits the pulley? The total distance from the beginning until you hit the pulley is 2 meters. So you have traveled only 1.56, which means this is less than 2. Therefore, what does it mean? Particle A, does it reach the pulley? Particle A does not reach pulley. Does not reach the pulley. Okay, so I hope this is clear with all of you. So this is the end of the Jan 2020 mechanics paper.